We will be starting momentarily. Please stand by. Let me give it another minute to get several folks in. I know we had a large group, so we will be starting momentarily, probably another minute or so. Thank you for your patience. All right. Well, it looks like we can go ahead and get started. Welcome everybody to Tooling Time, where this is the show where we dive into the latest enhancements, tips, and best practices in Siemens manufacturing and engineering. Whether you're tuning in to enhance your expertise or explore cutting edge tools, this is the place to be. I'm Alex Storman, the marketing manager here at Swoosh Technologies, and it's so great to have all of you with us today. Today, we are actually thrilled to be putting the spotlight on one of the most powerful tools in Siemens ecosystem, which is NX Process Planner. This innovative solution is transforming how manufacturing planning integrates with design data to streamline workflows, enhance productivity, and optimize processes. From sequencing operations to aligning tolerances, NX Process Planner is a game changer for manufacturers of all scales. And we couldn't explore a topic this impactful without bringing in the best of the best. Joining us is none other than our very own John Vinson, technical director here at Swoosh Technologies, a trailblazer in NX CAM with unparalleled expertise in post-processing, milling, manufacturing, and CNC programming. John is here to share his insights and give us a first-hand look at how NX Process Planner can revolutionize your workflows. Trust me, you don't want to miss this. John, welcome to the show.
Thank you so much. It's an honor to be here, and I'm certainly excited to dive into NX Process Planner and show the viewers here how we can really take manufacturing planning to the next level. And if you certainly have any questions, feel free to drop them in the chat, and we will be here to answer as we go through the material.
Awesome. Now let's go ahead and get started with what John has put together for all of us.
Hi, everybody. Welcome to Tooling Time, presented by Swoosh Technologies and me, John Vincent. And we're going to be kicking off this episode today covering model-based part manufacturing, and we'll talk a little bit about what is model-based part manufacturing, what tools are we going to use inside of NX, maybe some benefits to the company, benefit to individual users, to spread some awareness of these tool sets. Um, but for those folks that have been around for a while, we used to do these episodes and kind of fell off our radar. But we're going to bring them back. I think a lot of people found them to be beneficial. Um, so if you do enjoy them, please let us know, and we'll make sure that we continue to do them and cover more and more content. All right, so with that, let's go ahead and just talk about model-based part manufacturing, or you'll hear it referred to as MBPM. And what this really is a process or digital thread, to throw some buzzwords out there, that enables us to design our 3D models of our parts. Again, whether we're designing things in-house for our own company, or maybe we're getting models from a supplier, but really to contain the whole recipe to go ahead and produce that part or that assembly. And we're able to do that by containing all this data inside a CAD model, as opposed to traditional sense where we're doing things like using an ERP system to maybe track what materials are being used, or to build process steps of how we're going to produce this part, and work centers that we're going to, or outsourcing certain operations or features, or anything along those lines. So that's what I'm going to start with this episode today, is kind of showing a high level of how we can do this. And I think we're going to take a couple episodes to really get through the whole picture of what can truly be done with model-based part manufacturing. But just to talk about some of the benefits and the reasons why you may want to invest the time and effort into using model-based part manufacturing, as opposed to whatever your current practice is. Again, could be using ERP, MRP systems, manufacturing execution systems. Maybe a few of these scenarios tied together. We'll also talk about down the line here on how we can work inside of NX and maybe export this data to systems we already have, so we can keep some continuity throughout an organization. But in the end, we're really going to be speaking to a few things, kind of a common thread in this discussion. Having one source of truth, really not just from the standpoint of having a part design and maybe not working with a conventional two-dimensional drawing anymore. That was kind of an early iteration of model-based part manufacturing. But now we're going much further past that. We're going to want to have all the data to produce this part inside of NX and inside of our part file. This is really going to enable us to be a lot more efficient in our programming operations, inspection of our part, operating our manufacturing execution systems, managing vendors, and when, why do certain features need to be handled at an outside vendor. And all of this will be derived and driven from the bill of process, and that's going to live right with our part model. So, in addition to improving some efficiencies, quality is going to be another thing that is enhanced. Less room for errors, less opportunity for errors. That's important in this process, really embed that quality aspect. And we're going to go ahead and also do things like removing paperwork, or have the ability to remove paperwork. Yes, some people still like to have paper prints of their part, or to have a traveler that goes around the shop floor with a part. Can always still do those things, but we may no longer need to do those things. And future growth and scalability is going to be better enabled here. As manufacturing grows and expands in its technology here, to be able to contain all these things inside of one platform is going to enable us to kind of grow to new heights. Maybe your organization is going to look at doing some 3D printing, or different types of additive machining. We can show how we can embed all that stuff inside of MBPM, or how it's all going to tie together. All right, with that, I think we're going to go ahead and jump into NX and start taking a look at some situations of what a real workflow might look like inside of your company. All right, so here we are inside of NX. And during this discussion, I'm going to play a couple different roles here. Right now, I'm going to start out as a manufacturing process engineer. So I'm going to go through things like examining this part that I have in this scenario. And we'll say this comes from our internal design department. I'm going to kind of review this part, um, look at the data that's been provided here in this a little bit of a mess of PMI and MBD data. And I'm going to go ahead and kind of make some determinations. Where do I want this part to be produced? What raw material am I going to be using? Inspection, when do I need to do inspections in my process? Evaluate if there's any requirements for outside processes, and start documenting those right inside of NX. And then we'll go and continue down that workflow, maybe looking at what does it look like to hand this over to CNC programming department. In between here, maybe we'll kind of blur the lines, and as a process engineer, maybe it's also my responsibility to create the manufacturing setup or work holding for the particular operation. Kind of show how that can all be done, again, right inside of NX. So we have this housing that we're working on. I'm going to go ahead and jump into our modeling application. And I can start by reviewing, some of the tolerancing features that are on this part to make some determinations about, maybe work centers, work holding, things of that nature. So I'm going to start because I need to create a bill of process here, which, again, more conventionally, you maybe heard of as travelers, routers, routings, depending on where you come from. And it can be created in a host of different locations. Again, ERP, MRP, MES systems, big variety of what we can do. But in this scenario, when we're embedding everything inside of NX, we're going to start this by creating what we call a bill of process. And the bill of process is going to contain all of this data. So inside of NX, we can build templates for our bill of process. Maybe we start mapping out our processes for family of parts or like parts, things of that nature. But in my scenario, I'm just going to go ahead and start working with a blank template. We'll see as soon as I start the bill of process application, I have the new toolbar, a new tool set up at the top of our session of NX. And this is where I can go through and start creating things such as my operations, steps within those operations, assign resources. Resources can be machines or people, make pages, devices, anything like that. I'll assign models to each of these steps. Maybe make sure I'm specifying materials. We can classify employees into various roles to know that, oh yes, I need a person that can operate a bandsaw at one point versus somebody that can operate a 3-axis milling machine or a 5-axis milling machine, or assembly. And as we progress with this process, we'll also go into how we can create work instructions for all steps of the process and really build these in a reusable manner. To go ahead and start for right now, I'm just going to start by creating my first operation. So I've looked at my part. I kind of have an idea already of how I want to produce this part. I think I'm going to be able to do it in 2 milling operations on 2 different work centers. But before I can do any of that machining, I am going to have to create a sawing operation to saw some bar stock. I'm also going to have to do some inspection on this part, and so I'll start laying this process out. I'm going to do this in a very manual approach right now. We can get into creating libraries of operation steps and things like that, but I'm not going to do that just yet. So really what I'm going to do is I'm just going to start by creating some operations. So I think I'm going to do this probably in 5 operations. I think I'm going to do a sawing operation, a milling operation, an inspection operation, another milling operation, and a final inspection. So in this case, I'm just going to start kind of laying out my process here. And I'm going to start by sawing my material. I don't even know what I'm going to need for material or anything yet, but I'm just going to kind of create the structure. And here I'm going to add new operations, and we'll do CNC milling. And I think this will be on a 5-axis. And then we'll add ourselves a QA operation, QA inspection. And maybe we'll copy and paste our milling operation. I think I can do the last operation just on a 3-axis machine from when I was kind of looking at my part model. And let's expand our dialog here a little bit. You can see we're getting our sequence numbers automatically as we're adding operations in here. And maybe this one will be final inspect. All right, so we got our 5 operations created and laid out in this scenario. And we'll go through and start adding some additional content here in just a moment. But maybe before I get into adding details, I need to learn a little bit more about my part. I need to kind of understand what size material I'm going to use, maybe start laying out what these operations are going to do. So I can see, if I start looking at my part model, I can see there's a overall length of 213 millimeters. Let's see, the width of part looks like 133, and the height of the part is 100. So, I can go through, and again, if we have create libraries of what inventory do we have for raw material, things of that nature, I could go ahead and start looking through that. But for our sake, I'm just going to add some notes in here right now. And we'll say that this is going to be, we're going to use 150, material that's 150 millimeters by, let's say, I think I can get away with 120 here for the height. I'm going to hold on to this thing. And we're at 213. Yeah, maybe we'll just go, maybe we'll add 5 millimeters on the side here. So 150 by 120, saw to 223. All right, so I'm just, again, creating my structure. So let's go through, and I can do a couple different things. I can start assigning resources and where I'm doing this, but maybe I want to start by actually laying out and start looking at creating some staged models. That's a nice tool to use in conjunction with the model-based part manufacturing. So I'm going to do that. I'm going to go ahead and launch the stage model application and start ourselves a new stage model set. And as I do that, I think I'm just going to be able to do this with 2 additional stages. All right, so here we can see we have our final part, our finished part is our housing, and we have 2 additional stages. And we can build this material in a few different ways. One, I may want to, at my housing part, let's make this a little bit bigger, use a command like bounding body. And here we'll go ahead and select our model and see that yeah, we're getting our kind of overall size from our part. And I could create this and maybe make some modifications here, or I could start doing some offsets and applying values in a different manner. Lots of different ways to achieve what we want. But I'm just going to create this kind of bounding body right now. And just to make viewing a little bit easier here, maybe we'll go ahead and look at suppressing our PMI. And now we had already said that we wanted to use material of a certain size here, 150 by 120 by 223. So let's do that. We know that this material was 213 originally, So I'm going to add 5 millimeters on a side. I like to use the synchronous modeling functionality for doing these sorts of things. So we'll just start offsetting our material as we see fit. All right, so I have some material laid out here. And I don't want this to really live inside of this part file. I just created it here. So let's go ahead and create a separate model for our material. We're going to jump to our Assemblies tab. We can create a new component, and we're going to move this body over to a different part file. All right, so now we have a model in here. Let's go ahead and save this as our blank material. All right, so we're starting to get things laid out. We'll jump back to our stage models. And we're going to start making some additions here. So maybe I'll jump to my housing stage 2. And let's reorder our windows a little bit. We'll put that over here. And the first thing I'm going to do is create a link body. And I will do, let's go to geometry linker. We're going to go ahead and link our blank stock. So stage 2, this is going to be my final, or my starting part. We can we can see that as we linked geometry between the two, we have part navigators kind of embedded in each of these stages. So I'm going to go ahead and do a similar activity or action inside of stage 1, where I'm going to start by linking my finished part geometry. And I'm going to do a second link of the blank geometry. So I'm going to create a stage model at this point of just the essentially the result at the end of
Seems like we're having some technical difficulties on some of our audios. It might be a connection issue, but let's see if we can get this going again.
Initial housing, which is going to be our final part geometry. All right, excellent. So go ahead and give all of this a save. And with all these stages, we can go ahead and continue on with our process. So I'm going to jump back and start looking at my build process again. And I'm going to start with starting to assign some resources and some models and things of that nature. So here I'm going to start with adding in a model. I'm going to look from my stock part and select my stage 2. And I'm going to do this for a number of different operations. Stage model 1. And so my stage model for stage model 1 is going to be what I'm using for my first milling operation, but it's also going to be what I'm using for my first inspection operation. So I'm attaching the same model to multiple operations. And same scenario here with my, oops, delete, let's get rid of that one. And there we have our stages all assigned, our models assigned to each operation. And we'll go through and start picking out some resources. So again, maybe here we'll just take a look at certain library settings that we could use. So in this case, maybe I just want to dictate where is this going within my shop. This could be starting to get into individual machines, into different equipment. But in this case, I want to start with just specifying that, hey, this is going to happen in my machine shop. And let's go ahead and add this to our sawing operation. Again, we're going to add this a number of times here for our milling operation. We're also going to do some other things. Let's get for our inspection, specify our quality control zone. And that's where this part's going to go for both of the inspection operations. And these are things that can drive process of the actual motion. How do we get from one spot to the other and executing things in our MES system? We can look at these resources that we've been assigning to the different tasks. I can go through and on the milling operations, whether it's a manual milling operation, CNC, and start assigning tooling. Maybe I want specific tooling. We got some great enhancements coming out in the June release that will automate this step. Really, really cool stuff. But that's getting ahead of ourselves here a little bit at this point in time. So let's go through and start seeing what we have right now. We have our material being sawed. We have the locations of where this is going to be. Maybe we want to add additional resources, picking up specific machine tools. Again, I have some just generic machine tools and equipment in here. Let's pick our NC milling machine for an example. And these pieces of information here all have data behind them. What can we actually do on the equipment? Looking at size limits and capabilities. So it can really help a process planner such as myself, understand which piece of equipment is going to be appropriate for a given job. So far we've seen creation of a very basic build process at this point in time, but also using stage modeling as part of this whole model-based part manufacturing process. And now we can continue to move forward with looking at using these stage models for manufacturing operations. So now with my housing stage 1 open, I can start a new manufacturing template to start the setup file for the CNC programmer. So I'll go through and select just a general template for right now. We can see that we have our part file in here. Take a look at the assembly tree. Yep, we have our stages. First thing I like to do is create my link bodies, because I always like to program off of my link bodies. Let's start by, there's our raw material, and second will be the actual staged model. All right, so we have our part set up, and now we can go ahead and add some fixturing. Perhaps we'll go to our reuse library into my fixtures and pick whichever fixture may be most appropriate for us for this given part. And once we have that, we can go ahead and start putting some constraints, just as we always would in any given setup here. Nothing special, given the fact that we are doing model-based part manufacturing. So let me go ahead and put a couple more constraints on here. And there we have a vise holding our part that we should be good to go for creating the next operations now. Or getting into giving this to our programmer to start their portion of the work. Maybe I'll even go through and bring in a machine tool for them. And now we're ready to hand this down to our NC programmers and let them go ahead and start creating the tool paths and creating the operations. And of course, since we're all in one system here, it becomes very easy to provide feedback from downstream back to the left here for either manufacturing planning, maybe we need to change machine tools, add operations steps, maybe other things about raw material. Maybe it gets identified that we need bigger raw material or less raw material. Whatever the situation may be, we can address that all real easily now that we have all of this manufacturing-based part manufacturing inside of NX.
All right. Well, thank you, John. That's a wrap on episode of Tooling Time. We hope you learned some valuable insights into how NX Process Planner can transform your manufacturing workflows and make your team even more efficient. Thank you. A huge thank you to John Vinson for sharing his expertise with us.
Yeah, it's always a pleasure to be here, and I can't wait to join for our next episode to talk more about these topics.
Yeah, speaking of the next time, make sure that you stay tuned to the next episode when we talk about NX process modeler and instructions. You definitely don't want to miss it. And if you want to sharpen your skills or grow your team's knowledge, don't forget that we also offer NX training classes, both virtually and on site, tailored to fit your schedule and your needs. And don't forget to mark your calendars for Realize Live 2025 in Detroit, Michigan, happening June 2nd through the 5th. Swoosh Technologies will actually be there exhibiting at booth 116, and you'll have a chance to meet John and his co-present as he co-presents with a special guest that we're going to keep under wraps for now.
That's right. You're not going to want to miss it. And don't forget about the giveaways we'll have.
Yeah, that's right. Stop by our booth to make sure you can enter to win one of two Space Mouse Pro wireless devices, the new Bluetooth devices. It's going to be an event-packed, innovative learning and lots of exciting moments. Well, thank you for joining us for Tooling Time, and make sure to like, follow, subscribe, and if you don't, and so you don't miss our next episode, and visit us at Realize Live. Until then, keep innovating, building smarter, and we'll see you soon. Thanks, guys. And I'm sorry for the audio that we had issues. We will go ahead and send this out afterwards, so be on the lookout for the rewind. Thanks, guys. Have a great day.